Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
During the Android show 2026, Google introduced Gemini Intelligence, a structural update designed to automate tasks across the mobile operating system. The features began rolling out this summer, starting with the Samsung Galaxy S26 and Google's own Pixel 10 series. Traditional mobile operating systems are built on a passive architecture, where the OS waits for a user to manually navigate between isolated applications. This design creates friction. As the boxes show, apps exist in silos. The human user must act as the routing layer to move data between them. Gemini Intelligence introduces a native routing layer, represented here by the neural mesh, which bridges these application silos. This change transitions Android into an Agentic OS, a system capable of executing complex workflows across multiple different apps. To see how this works, we must look at the three layers of the new stack. Layer 1, context ingestion, Layer 2, intent automation, and Layer 3, the generative interface. In a modern mobile environment, a simple tool is no longer enough to handle multi-step tasks. The software must be able to act on the user's behalf. Layer 1 is context ingestion. Before an agent can act, it requires a continuous awareness of the user's current digital environment. The Proactive Assistance module manages this by constantly analyzing real-time on-screen activity and incoming notifications. The system extracts data nodes from productivity apps like Gmail or Calendar, pulling them into a centralized hub at the base of the OS. This data feeds the Gemini Personal Intelligence module, organizing the raw information into a structured context window. This allows the OS to move beyond simple autofill toward relational data mapping, understanding how a date in an email relates to a field in a web form. For example, the system can fill out a registration form by identifying and pulling specific details from a calendar event or recent message. This ingestion layer is restricted by user-granted permissions, ensuring the system only accesses what is allowed. All proactive features are optional. You can disable screen analysis or cross-app data ingestion directly within the system settings. Without this secure, continuous layer of environmental awareness, predictive automation has no factual basis to function. Once the system has context, it moves to Layer 2, intent-driven automation. This is where the OS converts a user's goal into actual steps. We can see this in action by watching Gemini convert a raw text list in a Notes app into a completed grocery delivery order. The process begins when the user long presses the text list on the left and gives a natural language command. Gemini's language model parses the raw text, turning entries like milk or apples into distinct, actionable data nodes. The system then maps these nodes to the specific search parameters required by the third-party delivery app's API. Finally, Gemini interacts with the interface to add the items and verify the cart is ready for checkout. This process removes the need for the user to manually open apps and search for every item. This is app automation, where the OS runs hidden sessions within third-party software to execute tasks in the background. This logic also applies to the web through a new feature called Auto Browse in Chrome. Auto Browse acts as an autonomous agent, navigating through the complex pathways of digital sites to reach a specific goal. It automates online objectives directly within the mobile browser, handling the navigation and data entry on your behalf. This allows the system to book parking spaces or update e-commerce orders without the user clicking through every page. Intent-driven execution changes the user's role from a manual navigator to a supervisor who simply approves the final result. Layer 3 is the generative interface. Standard, rigid screen layouts are often unable to display the dynamic results produced by AI agents. To solve this, Google introduced Create My Widget. Instead of using a standard developer-coded widget, the OS can generate a custom UI element, like this meal plan, based on a specific prompt. By moving away from pre-compiled layouts, the interface can change its shape and function to match the user's immediate intent. The system applies this generative capability to Wear OS tiles as well, creating custom smartwatch interfaces from the same natural language prompts. On the input side, the system uses a tool called Rambler to refine how users interact with the agent. Rambler captures raw spoken audio, restructures the syntax, and removes filler words to provide a clean text command for the OS to follow. All of these adaptive elements are tied together by a design language called Material 3 Expressive. Material 3 Expressive provides a framework that standardizes these generated UI components so they feel like a cohesive part of the system. This generative front-end is the necessary vessel to display the complex agentic work happening in the background. When we combine these three layers, context, execution, and interface, we see a complete architectural shift. This 3D model shows the stack in action: blue for ingestion, green for execution, and yellow for the generative interface. A single prompt triggers a cascade through all three layers simultaneously, connecting user intent to automated action. The OS now assumes the burden of the intermediate steps, leaving the user to simply define the desired end state. The challenge moving forward is ensuring these agents can navigate third-party apps, even as those apps change their designs and code. The system must maintain stable execution while interacting with the inconsistent and shifting interfaces of the broader app ecosystem. This technical stability must be maintained alongside the strict privacy controls that give the user final authority over their data. Gemini Intelligence establishes a proactive execution layer, moving the operating system from a passive tool to an active assistant that handles tasks on its own. For over a decade, mobile operating systems have functioned as a collection of isolated containers. Applications operated independently, requiring the user to act as the manual bridge between them. The announcements made at the Android Show 2026 represent a structural evolution away from that model. With the introduction of Gemini Intelligence, Google is transitioning Android from a passive application launcher into an active, proactive orchestration layer. This diagram illustrates the shift. Left, the discrete app model requires manual navigation, extracting data and carrying it over. Right, integrated orchestration. The operating system intercepts a single intent and autonomously executes steps across applications. This architectural update begins rolling out to hardware in the summer of 2026. It will launch initially on the Samsung Galaxy S26 and the Google Pixel 10 series. To understand how this works in practice, we need to look past the surface interface and examine three new macro-architectural layers added to the stack. Before an operating system can act autonomously, it must be able to read and interpret its immediate digital environment. This wireframe diagram shows how Google's proactive assistance engine fulfills this requirement. A transparent Gemini layer floats directly above the active application layer, analyzing on-screen activity in real time. This system parses data beyond just the active screen. It pulls background notifications and data from core applications like Gmail and Calendar into an isolated local processing box called the context engine. This context engine drives Gemini Personal Intelligence, which functions as a highly evolved iteration of traditional autofill. By utilizing these continuously parsed entities, Personal Intelligence autonomously populates complex forms across the operating system. Continuous environmental parsing creates obvious privacy risks if left unchecked. To manage this, the architecture relies on a rigid permission gate. The AI can only access data from strictly user-approved applications. Furthermore, all of these proactive parsing features are optional and can be universally disabled in the system settings. By solving the context problem with local, permission-gated parsing, the OS is prepared for autonomous execution. Once the system establishes context, it requires a mechanism to turn that context into action. Google refers to this execution engine as app automation. This pipeline diagram maps out Google's primary engineering example. On the far left, we have an unstructured bulleted list of grocery items inside a standard Notes app. When a user long presses that text, the Gemini parser extracts the raw list entities and routes them into the central Gemini orchestrator node. Here, the orchestrator translates the unstructured items into a structured payload and identifies the correct third-party target application. In the final execution phase, Gemini autonomously pushes that payload directly to a third-party delivery or rideshare app, instantly generating a completed shopping cart. This execution logic extends beyond native Android applications into the mobile web. The browser equivalent of app automation is a tool called Auto-Browse in Chrome. Auto-Browse automates complex online tasks, like booking parking or updating orders, by navigating web document object models directly. This specific web orchestration capability will be deployed later in June. The operating system no longer requires the user to manually extract and paste data between applications. It routes and executes intent autonomously. This brings us to the final component, the interaction layer, where intent becomes data and data becomes interface. Traditional, pre-compiled graphical interfaces are static. they struggle to accommodate highly variable user requests. This data cleaning pipeline visualizes Rambler, the new intelligent input preprocessing layer. Raw conversational audio enters as a messy waveform. Rambler intercepts the spoken input and restructures it. By algorithmically stripping out filler words, it outputs a perfectly clean linear string of operational text. That clean data string is then routed into the system's output compiler, a feature called Create My Widget. Natural language prompts, such as requesting a weekly meal plan, are compiled on the fly into functional user interface components. The primary outputs of this compilation are custom home screen widgets and Wear OS tiles. To ensure these generated interfaces adapt visually across the ecosystem, the compiler standardizes their layout using an underlying design language called Material 3 Expressive. User interface is no longer strictly a static destination built by developers. It is a transient element generated instantly in response to user intent. When we step back and synthesize these individual features, we see a complete blueprint for an agent-based mobile stack. This master architecture map shows the system layers. We start at the bottom, traditional application sandboxes and Chrome web DOMs holding raw data. Directly above sits the new middle layer, the Gemini Intelligence Orchestrator, featuring the context engine, execution engine, and UI generator. Separating these layers are strict privacy barriers and permission gates. Finally, the top layer is the user, whose intents and inputs cascade downward into the system. The middle intelligence layer ingests the environmental data and cleans the unstructured user input. It then executes multi-step workflows across applications on the user's behalf. This proactive model runs concurrently with the traditional app stack rather than replacing it. Android has transitioned from a digital tool requiring constant manual navigation into an autonomous agent that dynamically